Okay, so in this video I want to discuss how to use the microbit to read two individual LDRs. Now in the last video I discussed how to do that with one LDR and directly to the microbit itself. Now this time, even though it is possible to connect up these two LDRs directly to the microbit, I want to add an additional component, which I'll explain why in 2 seconds. So this is going to be the additional component we're going to use, which is actually a breakout board, which adds a bit more functionality to the microbit itself. The microbit actually just clips directly down into it like so and gives you a bit more functionality. It actually gives you all the pins down along here and brings them out to these little pins below here, while also adding some servos, functionality to run stepper motors as well as normal motors, 4 of them here and 2 steppers, and also allows you to add in to about 10.8 volts I think in from this block, while still only supplying 3.3 to the board, so it doesn't fry anything on it. Now the reason for me wanting to show you how to set up your two LDRs with the breakout board instead of just to the microbit itself, even though possible, is because when you're using two LDRs, people tend to only do that if they are making a robot such as a line follower or a sumo robot or something similar to that, where you need to identify where you are, maybe on a ring or on a track, where you can see if you're on black or if you're on white by the different light values that you're getting in from these LDRs themselves. Now if I was to directly attach up these two LDRs to the microbit by itself, I would be able to read the values, but I wouldn't be able to, well, not so easily anyway, run motors or steppers or whatever other functionality you want after getting those values. So what I'm going to do is show you how to run these two LDRs directly with this board on the all-in-one Kitronik breakout board or robotics board. And after that then we're going to discuss how to set up a line follower, and then hopefully to a sumo bot, where we're also going to bring in an ultrasonic. So for this video what we're going to need is we're going to need some other additional components. Like before, we're going to need some sort of a jumper or cables which is going to carry power between the different components. We're going to need our power bank itself, which is going to supply the voltage. This time I can go a bit larger than I had the last video, because I'm going to supply it directly to the board itself, which can take up to 10.8. It should be 9 volts. And it still only supplies the 3 volts to the board itself. We're also going to have our 10k resistors. I just have them tied up here so I don't lose them. And we're also going to have this bit of a cable which is going to go from our power supply back to the board itself, to where the black and white cables go back in here. And we're also going to need these jumpers. Now the reason we need these kind of pins, or these jumper pins or whatever you'd like to call them, or these jumper rails, is because this board actually doesn't come with these pins stock. Now this board does have it on it because I soldered it on myself, but if you do buy these boards, they just come with these individual holes down along here. Now the problem with that, if you're using this in a classroom environment and you want to reuse this, it can be quite awkward to do so, because when you have your wires directly soldered to the board, it can be tough to unsolder them and take them away again without, causing some issues. So what I suggest is that you buy these rails. They're actually quite cheap. They should only be a few cents for a rail. You break off how many you need, you slot it down in, and then you solder them to the board yourself. Now they're the main components that you need. Now what we're going to do is just show you how the wiring goes together. It's quite similar to what you saw previously in the last video, but this time obviously because we have the two separate LDRs, we're going to have some additional connections. So I'm just going to zoom out a small bit here. And first of all, I'm just going to show you the wiring itself. Now I'm also going to have a wiring diagram up on the website, and you should be able to see that within the description below if you're watching this on YouTube. So we have our two LDRs, similar to last time, and the LDR has basically 3 different wires coming to it. You have your ground, as you can see here. you're going to have your cable carrying back the value itself, and then you're going to have the cable which is going to be carrying the 3 volts to power it. Now the only difference here is that our power is divided into 2. So as you can see, power still comes from the same place, except it's going out to the 2 different LDRs now. And we also have our ground is shared also. It's going to go back to the same ground, but coming to the leg of the end of the resistor again. But our 2 basically signal cables, or the value where it's coming back, are going to be 2 separate wires, as you can see here, so that you can read the different values from the 2 different LDRs. Now what I'm going to do is I'm going to quickly identify what things are, so it's nice and clear. So we have our 3 volts there, which is actually 3.3, that comes from the microbit. 3 volts is fine. 3 volts. We also have our ground, which I'm just going to mark here. Like so, and ground. Like so. And then we're going to have our signal coming here. So I'm just going to call this pin O. So I'm just saying that this is going back to pin O itself for one of the signals. And the other one, what color haven't I used? Blue. And I'm going to call this pin 1. Now it doesn't really matter what you call these, as long as that they're going back to a pin that reads an analog signal back to the microbit itself, which we discussed previously. Also on the website you'll be able to see the different pins identified on the microbit itself and which ones can read an analog signal. Now the 3 main ones on the board themselves, so 0, 1 and 2, all can read analog, so I tend to stick with them first of all, and then I use the additional ones later, as long as I've identified that they're analog. Now again, analog signal comes from your LDRs as well as sensors such as your ultrasonic. Now all we have to do is connect them back. On the board itself, you can actually read the different pins, as you can see here. Now our 3 volt, which is here, and our ground actually get represented over here now. So you can see that this one here is our 3 volts, and we have our ground all the way up here at the top, and we have pin O should be below here, the second one up, and pin 1's all the way up here. Okay, so we just have to connect our appropriate cables. So our ground here, we'll go back to ground. Our 3 volts, we'll go back to our 3 volts. The blue here I said is pin 1. So look for pin 1, should be this one. Be nice and careful, just in case you pick the wrong pin. And then pin O, which is the second one from the bottom here, like so. Now that you've it all wired up, all you have to do is go over and sort out your code so that you can read each of the values from the pins directly off of the matrix here, the 5x5 matrix on the front of the microbit itself. So we're just going to jump over now and check out that code. Okay, so now that we've moved back over to our microbit coding application, we can start writing out our code. Now last time what we had is we had our forever block here, and we also had our basic show number. We had our pin, which we had our analog read pin, and we also had a pause, so to give time to the microbit itself to read the value coming back to that pin that we had selected. Now the problem with using this exact piece of code is that now we have 2 individual pins. Now we could, change the code each time and change it to the pin we want to read, but what we want to do is have those 2 pins ready to read at any time. So what we're going to do is keep this section of the code, we're going to get rid of our forever. And instead of going to our basics this time, we're going to go to inputs, and we're going to go on button press. Okay, so on button pressed, duplicate it because we have our 2 buttons. And the 2 buttons we're going to be using are the buttons actually already here on the microbit themselves, button A and button B. So we have on button A pressed and then on button B pressed. Okay, we're going to put this code into one of them first of all, and then we're going to duplicate this piece of code and put it into the other one. Okay, like so. Separate them out so they're not overlapping. And we're going to change this analog read pin to pin 1. So now we have 2 separate pins that are going to read on 2 different button presses. So according to this, if we press button A, what it will do is run through this, which it will first of all show the number on analog pin 1, and it's going to also pause for 1 second just to ensure that it gets a consistent value. Then on press B, it's going to read the other LDR and show us the value from that's coming into pin 1 from that LDR, and wait that 1 second. Okay, so now that we had a look at the code, what we can do is upload that code to the microbit itself. So all you need is your micro USB cable, plug it into the top of your microbit and download it on. Now I already have it downloaded to this microbit already. After that, we need to connect our power. Now, last time we had a smaller battery pack. The reason we can use a larger battery pack this time is because it's going directly to the breakout board itself, which is capable of taking up to 10.8 volts, and then steps down the voltage for the microbit itself down to 3. Just ensure your switch is on at the back. Mine is already on. You'll know it's on because it gets power directly to the board and puts on this green light, as well as you can see that it's getting the power to the microbit because there's a little red light on below here. Now we've it set up like you saw in the code that on button press A and B we get the values of the LDRs to read. So on button press A we should be getting the value from the LDR here on the right. So if I click that, it will give me 871. If we click it again, 870. Okay, so I'll put my finger over that LDR this time and see what we get. 661. Try it again. 651. Okay, so as you can see, I put my finger over it, the value got lower. If I take it away again, it should be up in the 800 marks. So 865, finger over it again, and we're down to 620. Try that again. 625. Take away my finger. 857. Okay, so that's working perfect. Now if I try B, press B, I'm getting 829. Put my finger over the sensor on the left. 588. Press it again. 583. Take away my finger, and we're back up to 829. Okay, so that's working perfect. So that's basically how you set up a microbit to read 2 separate LDRs.